What's up, guys? We're going to start chapter 11.1, designing a study. Students will be able to classify study types and design statistical studies. Your homework is a worksheet that I've attached. Pretty easy lesson, to be honest, so we're just going to jump right into it. The first thing that we're going to talk about is in a statistical study, data are collected and used to answer questions about a parameter. A parameter is essentially just, it's something that we're curious about. Okay, examples of parameters could be the height of a person or the test results, right? Those are all parameters. It's the thing that we're looking for in an experiment. Oh, that's a better way of putting it. It's the thing that you're looking for in an experiment. Okay. The steps of a study is identify the objective, choose a sample, collect data, organize the data, calculate sample statistics, make inferences, and draw conclusions about the population. Okay, a lot of you guys are heading to stats next year, and that's what a lot of this is going to be about. Biased and unbiased. To obtain good information and draw accurate conclusions about a population, it is important to select an unbiased sample. A bias is an error and misrepresentation of members of a population. So a bias is something that can sway a person, that can sway like an opinion of something. Okay, a bias. Example, asking who's better, LeBron or Kobe, but you're doing it in Los Angeles. Of course, people in Los Angeles are going to say Kobe is better because, you know, it's Los Angeles, right? It's like where Kobe played. That's an obvious bias. It's a location bias. Okay, we're going to ignore this last part right here in your group. We're just going to ignore that. We're going to move on. Let me give you another example of a bias. Another example of a bias is asking a basketball player what's their favorite sport. That's a bias because you're obviously asking a basketball player, right? Like, that's a bias. It doesn't really represent the population. You gotta pick a question and a population that will give you the best unbiased answer. You can't have anything that sways people one way or another. To reduce the possibility of selecting a biased sample, a random selection can be taken. Okay, so we wanna take people randomly. We don't want to necessarily ask our friends or family members, right? We want to ask people at random. So these are the three types. I'm just gonna really quick go through it. A survey is you're literally asking somebody, okay? In a survey, you're asking somebody a question, they're giving you a response. That's a survey. In an experiment, you're doing something to somebody. Okay, you're actually manipulating. You're not touching them in a survey, you're not giving them anything in a survey, you're just asking them a question. What's your favorite color? That's a question. In an experiment, you're actually doing something, right? You're actually doing something to the subject. And then finally, in an observational study, you're just watching them. Okay, observational is you're literally just watching them do something. You're not asking them anything, you're not giving them anything, you're just watching how they react. Okay, you're just watching them. Okay, so we're going to determine which one's observational, survey, or experiment. Okay, a record label wants to test 3 designs for an album cover. They randomly select 50 teenagers from local high schools to view the covers and record their reactions. Okay, this first one is probably going to be an observational. Okay, you're not testing anything, you're just giving them something and you're just watching them. You're not asking them a question, just watching them, okay? The city council wants to start a recycle program. They send out a questionnaire to 200 random citizens asking them what would they recycle. This is a survey. You're just asking them a question. And then finally, researchers, scientists to study the behavior of dogs given a new treatment. So in this last one, you're actually giving the dogs something, right? You're giving them something that affects them. This is called an experiment. Cool. Number 6. So I want to do the same thing. A pharmaceutical wants to test whether a new medicine is effective. What would you do? Would you do a survey, observation, or experiment? I would do an experiment, right? I would give the people the new medicine and then record their data like that. I would give them something I would give them to test something. Researchers. A research company wants to study smokers and non-smokers to determine whether 10 years of smoking affects lung capacity. So you're not giving them cigarettes, right? You're just watching people that already smoke or people that don't smoke. So that's called observation. And then news wants to randomly call citizens to gauge opinions. So you're calling somebody, you're not watching them, you're not giving them anything, you're surveying them. Pretty easy. 3, bias questioning. So questioning can be biased. One way is it's confusing or wordy. It encourages a certain response. Question causes a strong reaction. Address more than one issue. Okay, so you don't want to be too wordy or confusing. Questions can also introduce bias if there's not enough information. So your question should be simple, straight to the point. Okay, it cannot invoke any biases. So here's some examples. Determine whether the question is biased or unbiased. How often do you exercise? How often do you exercise? This is unbiased. There's nothing really there that affects you one way or another, right? Don't you agree that the cafeteria food should serve healthier food? This is biased. Because this part right here, the don't you agree, and this is going to be important. Don't you agree? By using that phrasing, don't you agree, you're already kind of saying that, oh, it's agreed upon, right? Like, you should agree with me already. It's already common knowledge, right? That don't you agree already kind of pushes you in the direction that, oh yeah, I agree, right? So you don't want to use that. How many glasses of water do you drink a day? This is unbiased. Pretty straightforward. Do you prefer watching exciting action movies or boring documentaries? Exciting and boring, those are your bias phrasings right there, because it kind of forces you like, oh, I'd rather watch exciting action movies than boring documentaries, right? Like, you shouldn't have those adjectives there because it pushes you to one direction. Designing a study. Jim is writing an article for his newspaper about online courses. He wants to conduct a survey. How many students at his school would he be interested in taking? Okay, so I'm doing state the objective. What's the objective? How many students? So the objective isn't to see if students are interested in taking online classes. Okay, to see if students are interested in taking online classes, that's the objective. Like, that's what we want to do. We want to see it. Suggest the population. So the population, so it would be random students, or his population would be his school, right? Because that's who he's essentially asking. His school students. But what he should do is he should ask, but he should be asking random students. You can't necessarily ask the whole school, right? You want to just ask not a handful, but you want to ask a good amount of students randomly. You can't ask the whole school. You want to ask students randomly. Okay. Identifying flaws. So let's check out some flaws here. An electronics company wants to test whether using a new graphing calculator increases students' test score. A random sample is taken. Calculus students in the experimental group are given the new calculator to use. Algebra 2 in the control group are asked to use their own calculator. When given the same test, the experimental group scored higher than the control group. So here, essentially what is happening, the flaw is that you're asking calculus students and algebra 2 students. Calculus students would probably know more than the algebra 2 students, right? Like, calculus students would just know more math, right? It doesn't really test the calculator, it would just test like the students' knowledge in general, right? So that's the flaw in this experiment, that you're asking calculus and algebra 2 students. Now, how you would fix this? Have students of same math level do experiment. Another thing I want to point out in here is it says experimental group and then it says control. Okay, experimental group is the group that you're actually giving like the medicine to or testing the new product on. So the group given tested thing. Control is group given nothing. Right? It's the group that you're not touching, you're not changing. The reason why we have experimental and control is because we want to test, like, does this new thing actually make a difference? And if it makes a difference, right? If it makes a difference, then they would do better than the control. Or if they do the same, then it wouldn't be much different, right? Experiment. A research firm tests the effectiveness of a de-icer on car locks. They use a random sample of drivers in California and Minnesota for the control and experimental group. They conclude the de-icer is effective. Once again, California is hot. Minnesota is cold. That's the flaw. You're not doing it at the same spot. The weather changes, right? Like the defroster would probably work a lot better in California because it's warmer, right, naturally. So to fix it, do experiment in, I don't know, I'm just going to be Minnesota. Only. Or California. Only. Okay. All right. That's pretty much it. Pretty simple lesson. Just a lot of vocabulary and application, but yeah, nothing much else to that. We're in the home stretch, guys. Keep working at it. Keep doing what you're doing. I'm very proud of you guys for like staying committed to this and trying to learn as much as you can. It really does mean a lot. Okay, because yeah, it means a lot to me. So just keep going with it, all right? See you guys.